Arrays play a pivotal role in JavaScript, much like in numerous programming languages. They serve as containers that group elements under a single variable, granting access to individual items via their indexes and facilitating iteration through loops. However, delving beyond the foundational concepts, arrays occasionally exhibit behaviors that might defy expectations. Some of these behaviors are inherent to many programming languages, while others are unique to JavaScript, regardless of their origin. These peculiarities can occasionally trip up developers, resulting in bugs within software. The objective of this post is to spotlight and elucidate several of these weird parts. Today, I want to dive into the weird features that make JavaScript arrays both fascinating and sometimes a bit puzzling, so let's roll up our sleeves and explore these quirks one by one. Number 1. Arrays are objects. Within JavaScript, each variable you declare neatly falls into one of two categories. It's either a primitive or an object. The roster of primitive types encompasses. Interestingly, arrays don't find themselves on this list. Why? That's because they're distinctive entities, special objects, to be precise. Let me explain this with an example. Now I have created an array named pets. JavaScript allows us to check the type of variables. In this case, we are curious to know what type the pets array belongs to. However, when you ask JavaScript using typeOfPets, it gives you a slightly puzzling answer. Instead of directly saying it's an array, it says it's an object. This might seem odd, but it's because arrays are a special kind of object in JavaScript. To make things clearer, we use another trick. We use a function named array.isArray, which is like asking a question. Hey, is this thing really an array? We give it the pets array as input, and it responds with true. This means, yes, the thing we have is indeed an array. In simple terms, JavaScript considers arrays as a specific kind of object when we inquire about their type using typeof. However, to be more certain and precise about whether something is an array, we use array.isArray. This function gives a more distinct response, helping to prevent any potential confusion. Number 2. Array length mutation. Imagine you have an array of items, like 1, 2, 3. Arrays usually work like a line of boxes. Each box holds something, and the number of boxes is the same as the array's length. But here's the curious part. We can actually change the number of boxes directly using the length property. When we do array.length is equal to 2, it's like we're saying, hey, shrink this array down to just 2 boxes. So the array loses its last box, and we end up with 1, 2. Number 3. Non-integer indexes. Think of an array like a set of drawers. Normally, we label the drawers with numbers, like drawer 1, drawer 2, and so on. But in JavaScript, we can use words as labels too, which is pretty cool. In the strange array example, we use the word name as a label and put Alice in it. But here's where it gets odd. These labeled drawers don't count as regular items. So, even though we see a label in there, the array's length doesn't change, and we can fetch what's inside using strange array name. Number 4. Changing array length. Imagine an array like a line of seats in a theater. We have seats for our guests, and if we want more, we add more seats, right? Arrays work similarly with the length property. When we change the length, we're telling JavaScript how many seats or slots we want in our array. Increasing the length creates new empty slots, like adding more chairs. So, when we do array.length is equal to 5, we're saying, hey, we want to add more chairs, make space. As a result, we get 1, 2, 3, empty. 2 empty spots waiting for something to sit in. Number 5. Comparison of arrays. Imagine we have two identical looking boxes, and we fill them both with the same set of toys. They look the same from the outside, but they're still two different boxes. Similarly, when we create two arrays, even if we have the same values inside, they're actually two separate boxes in the computer's memory. So, when we use array is equal to array b to see if they're equal, JavaScript checks if they're the same box, not if they contain the same stuff. In this case, array and array b are two different boxes with the same contents, so the comparison gives us false. Number 6. Deleting array elements. Imagine we have an array of items like 1, 2, 3. Now, what if we decide to delete one of the items? Say the second one, using the delete keyword like this, delete array index 1. The result isn't exactly what we might expect. The array becomes 1, empty, 3. The item at index 1 isn't truly gone. It's like we have left an empty space in its place. It's as if we have removed a book from a shelf, leaving a gap where it used to be, and this gap is not the same as undefined. Number 7. Nan and array.indexOf. Nan is a special value in JavaScript that means not a number. It's a bit like a mystery box in an array. If you try to find where nan is using index of, JavaScript's behavior might surprise you. It doesn't quite understand that nan is the same as itself. So when we do array.index of nan, it gives us -1 as if it's saying, I couldn't find that weird nan thing you were looking for. Number 8. Arrays copy by reference. We have a list of pet names that we store in an array called pets. It holds 3 names, Bambi, Caesar, and Che. Then, we create a new array called newPets and assign it the same values as the pets array. However, remember that newPets array is not an entirely new array. It's more like a pointer to the same array in memory that pets array points to. So, both pets and newPets now reference the exact same array. Now comes the interesting part. We decide to change the first and second elements of newPets. We set newPets index 0 to Jessie and newPets index 1 to Daisy, since array newPets is pointing to the same array as array pets. These changes also affect the pets array. When we log both arrays using console.log method, we'll see that both arrays now have the same values. This is because any changes made through newPets are reflected in pets. Now, we check if pets and newPets refer to the same array in memory. Since they do, the output of this comparison is true. In closing, we've explored some of the fascinating and sometimes puzzling quirks that characterize JavaScript arrays. However, remember that the array realm is vast, and there are even more intriguing features waiting to be uncovered. By embracing these oddities, you're diving deeper into the heart of JavaScript, equipping yourself with a more profound understanding of its capabilities. So, as you continue your coding journey, rest assured that these peculiarities are just the tip of the iceberg. Happy coding, and may you uncover even more of JavaScript's secrets.